Good evening, everyone. I hope that you all are doing great. My name is Hamza, and welcome to the series where we interview the industry leaders in the plastic injection industry. I will start by introducing myself. I'm an account executive at SimForm, which is a division of Maya HTT. Maya HTT has proudly served more than 7 million users across the globe in the last 40 years, and we primarily provide services in 3D simulation and software engineering. Today is a very exciting day because we have a guest who has more than 40 years of experience in the plastic injection industry and contains a knowledge that is unparalleled. I would like to welcome Scott. Scott, would you like to introduce yourself and tell us a little bit about SPE?
Sure. Thank you, Hamza. I'm Scott Peters. I'm currently serving as the division chair of the Society of Plastics Engineers Mold Technologies division, as well as a tooling manager and quality manager for M Design LLC here in Cleveland, Ohio. In my 47 years in this business, I've seen tooling design graduate from drafting boards all the way up to 3D modeling and CAD. And I've seen flow simulation start out from just, we're going to simulate how the material goes through into truly scientific approaches. Within the SPE, we offer the membership educational opportunities. There's a lot of research being done, and not everybody can digest the research and regurgitate it in a proper way. And so through SPE, we offer kind of that service where we are vetting the software, vetting different products, vetting different concepts and tool design, and becoming a repository for people to go in and do item-specific searches in their quest for knowledge. So that's the long and short of SPE.
I see. That is amazing. I feel like there needs to be a place where mold designers and molders can easily go and access that information. And I feel like SPE truly serves that in one way or the other. Does SPE also actively helps mold designers who are seeking ways to enhance their information actively? Is this also something that you guys actively partake in?
Well, we do have chat boards on the SPE website, the 4spe.org, and those chat boards allow people throughout industry to place questions and then gain information back, direct feedback, one-on-one from members throughout the society, whether they're, limited only in scope to the mold making and mold design division, or it's cross-functional injection molding, materials, and rheology. So we bring all facets of the plastics industry together and hopefully to bear on the question and get the right answers.
I see. Well, of course, I feel like considering you're in a very unique position where you encounter all the stakeholders within the plastic injection industry, I'm curious to know, what did you observe? What are their main challenges, for example, of the molder or the mold maker that you normally observe?
Well, typically it's getting a part out of the tool that is representative of what the product designer had in mind. And that can be through a number of things. We can look at the injection phase. We can look at the tooling and see that, the tool maker just really didn't understand what he was doing. Hopefully that's not the case, because that usually results in a lot of wailing and gnashing of teeth. Or it could be the injection phase when we're putting the plastic in. We have to control the profile of the injection so that we get the material in and don't overpack. And then the one area that is oftentimes not overlooked but discounted is the cooling phase. How do we cool it? How do we control the warp? How do we predict the warp? And so, of course, that's something that every molder and every mold maker in the world is scratching their head. How do we do this? How do we make it better? How do we shorten the lead time from tooling order to product in hand?
Very true. In fact, I feel like you have preempted my next question, which is now that we are talking about the cooling phase, I feel like mold makers and mold designers are, of course, uh, not actively thinking about cooling phase when they're actually starting, at least from the mold designer perspective. So I'm curious to know, number one, how would you explain to mold designer how important is the cooling, you know, and what impact can it have on a product quality or cycle time if it is not properly taken into account early in the process?
So first, I'll take exception to the statement that mold designers and mold makers are not actively concerned about how to cool. It is unfortunate that sometimes the last thought is given to cooling. There's so many things going into a mold. You know, you've got the cavity geometry itself, then you've got to figure out how to get ejector pins in. And once you've got all of those components, somebody will throw a side action in or a lifter. And now you have to kind of snake the cooling lines through. So while we think about cooling, it does become tertiary to the process.
Mm-hmm.
And then, you know, it's like, okay, I've got everything designed. How do I get the water in there? And sometimes we think we have to stand on top of the press with a watering can just to cool the part. I'm being silly, but you know, it does feel that way sometimes. You know, I've been designing molds since 1975, so I think I've got a pretty good eye, but I know I miss things a lot. A lot of people still go with Kentucky windage, that it's going to be hot over here, and then we adjust and try to put warp, or we may even build warp into the cavity to overcompensate. And having a tool in hand that allows us to quickly simulate the hot spots based on the material and the steel or the mold material types, hey, that'd be great, especially if it's fast. So.
Very true. Now, indeed, I think a tool that would be able to do a cooling simulation and identify hotspot would be very helpful for mold makers, mold designers primarily, though. Now, but considering most of the mold makers are not using that device, what are the what are the solutions that they quickly jump to, you know, right now, would you say, barring the usage of simulation tools?
Yeah, so without using simulation tools, of course, the latest buzzword in the industry is conformal cooling. And so there's a lot of people trying to find ways to 3D print cavities and cores that allow you to actually get the cooling channels in places that with a standard drill you can't get to. So there's reliance on that, but other than that, it is we look at using alternate materials, high thermal capacity materials. So if the majority of the cavity is a tool steel, and we know there's going to be a hot spot, we'll put beryllium copper in, or some material similar to that. So we get a much higher thermal capacity and can cool that area more quickly. Does it always work? Yeah, no. There's plenty of times where it worked halfway, and then we got to fade back and figure out how to get the second half to win the day. I don't know. I guess in my approach to tool building, I work with a three-legged chair approach. You know, so I've got the tool maker, I've got the product designer, and I've got the molder, and we work together in concert so that all three they're all primary stakeholders, and all three have to understand where they're going. Of course, the guy who designed the product, he's most in charge.
Right.
You've got to give me that part.
Yeah.
Right. That's that. Anything else is unsatisfactory. And then the molder is looking at it, and he's saying, hey, I need this thing to run. I quoted it at 25 seconds. I need it to run at 20 so I can make some money. And how do we keep the part control, and the tool maker's looking at it saying, well, you guys are both crazy. I'm going to build you a mold that's robust for my approach. But when you bring all three together, they can find a way.
Very true. And I think this is something that we have overheard from various stakeholders, whether they are, as you rightly said, part designers, or whether they are OEMs, or whether they're mold designers, that one tool that would be able to bring some kind of consensus between all these stakeholders would indeed really be a winner, though. Would you also say that, considering intuition is something that a lot of mold designers primarily use, it has an effect on the profits of the people who are producing plastic parts, though,
I would say absolutely.
Yeah.
Mold designers who have been around for 15, 20 years, they have really good experience and intuition to draw from.
Mm-hmm.
The problem, as I see it today and going forward, there's not a lot of people going into mold design. Not a lot of tool makers are training people because people don't want to do that. They think it's a dirty job. And so the intuition is walking out the door as people retire. So we have to replace intuition with technology. Even though you still have to have somebody that can interpret the technology, the output from the technology, but the experiential level is not there.
How would we incorporate a simulation software broadly into the plastic injection industry, where it would be right to recognize that they are lagging behind a little bit in terms of digital transformation? In terms of, I mean, there is a little bit of hesitancy, if I may call, in using the cloud services. Would you say that, or
oh, absolutely. I've got a 1 terabyte drive on my desktop because I don't trust it going to the cloud. That said, it is all about data integrity, right?
Mm-hmm. It would be right for us to state that if simulation companies or services are providing end-to-end encrypted services, it is in the interest of mold designers to really hop on and really take the benefit of this new technology.
Absolutely, as long as it's not two things: time prohibitive and cost prohibitive. Mold makers today are typically, we're hoping to work on a 10% gross margin. Well, a 10% gross margin, if we're going to take 3% to run a simulation, even if it pays back, it's a hard nut to chew.
Mm-hmm.
The other side of it is everybody wants their molds that much faster.
Everyone.
We want molds. I want a 4-week delivery. I was working on a program with a cellular telephone protective case company, and they said, well, we built, cell phones are good for 6 months. And then the next generation comes out, which means we've got to be building molds in 4 to 5 weeks. Those are very complex tools. And to build them in 4 to 5 weeks means you have to have a lot of things in place already.
True.
So we can't drag it out and have a long time in doing the analysis. And I think, in the past, some of the softwares, you'd set it up and let it run for 2 or 3 days. Well, part of that was the software, and part of it was the hardware. The computers were a step up from a flywheel start machine. So, we've come a long way with computers, and the software has been improved in terms of its portability and its overall performance. So we've driven that time down. But even 3 days, 2 or 3 days, send it out, have it come back would be a big delay in a 6-week program.
Very true. I think not only it would be a big delay, in my point of view, every day or every hour that you're actually not providing services to your customer in a timely manner, you're reducing your chances of that customer coming back to you, because that you're not providing the best service perhaps. So if there is technology that can reduce that lead manufacturing time, I think mold designers should optimize and integrate into their ecosystem as soon as possible.
As soon as possible.
As soon as possible.
You mentioned that if you're not providing that almost instant feedback.
Yeah.
I remember before the fax, okay, we would take a drawing and maybe we'd make a photocopy and put a letter together and put it in the mail. 3 days later, the customer would receive the letter, open it up and start digesting it. Yeah, okay, now we get the fax and we sit and the fax comes and the fax goes. And within a couple of hours, maybe we have something. Email has really driven the need for instant information. If I get an email from my direct manager right now and I don't have the answer in 3 minutes, I'm getting a Teams chat. Did you get my email? Whether I was out on a floor molding a part or not.
Or where were you?
Yeah. Why didn't you answer that? And so, while everything gets better with technology, the speed that we have to work is it's no longer walking, it's running constantly flat out.
Mm-hmm. So in that view, now if I move our conversation a little further, which is in terms of how would we convince, or would it be even right for us to convince the mold designer that there is a need for scientific method in the plastic injection industry rather than the intuition, though? I mean, we all know that there are benefits for that, but how do we materialize those benefits to them in real value?
Okay, that's a good question. And I'll answer it this way. One of my supply partners in mainland China saw that his mold makers were doing great work, absolutely fantastic work. His designers were spot on, the mold makers were executing, but they didn't have a sense of what scientific molding was all about, what decoupled molding was all about. And so he sent his senior designer, his lead mold maker, himself, and a customer service agent out and had them master molder certified at his expense. Now, he doesn't mold parts, he builds molds. But his reason for this was, with them understanding what we're talking about in terms of the injection profile, the cooling profile, how the mold functions, everything would be better. And he has won a lot more business and repeat business because of the excellence in work that he does. Having that kind of technology coupled with the intuition. I mean, let's face it, a mold designer is going to sit down, he's got to put certain things in, and he's going to have ideas about where cooling is going to go, but then running the simulation and saying, man, I missed it over there, let's do this or let's do that, will be an enhancement and will improve the overall product to the customer and hopefully the bottom line to the producer.
These simulation tools incorporate some level of scientific methods when they're providing us the results for cooling simulation or any other simulation. Then how do we justify the fact that simulation tools more or less have been in the industry for the last 2 decades, but we still see a hesitancy to adapt it, and again, the answer could be that perhaps folks are not that comfortable using technology, or would you say that there is also another reason that, considering simulation tools have been there for the last 2 decades, there is less than 50% of the folks using them?
Okay. So mold makers in general are smaller companies by and large, right? So you're talking 10 to 15 people. And with some exceptions, they're maybe a $2 to $3 million a year company, okay, in annual turnover. If they're making 10% gross margin, By the time they pay S&A and everything else, they're down below 5% in their pocket, and the cost has gotten in the way for a mold maker. Plus the benefit hasn't been there. So where we say that mold makers aren't using it, I can tell you that on certain projects, they do subcontract the work out. But that's got a heavy price tag as well.
Indeed.
So the software, cost of training has been a stumbling block. And then experience has been kind of bumpy along the way. I mean, you say only 2 years or 2 decades. I remember my first mold fill simulation in 1989. So it's been around a week longer than 2 decades. But I also remember that in that simulation, it was just a fill simulation. It didn't have the material characterization. And so people, we have memories, right? We remember, that was just terrible. They wanted me to change a runner diameter by 0.003 of an inch for every inch of run, and on and on and on. So I maintained perfect velocity. And I'm not doing it. Just, it's stupid. I'm not going to do it. But we remember that. And then people come in and, a sales engineer comes in. He may have the best things in sliced bread.
True.
But he comes in and I remember the last piece of sliced bread had mold on it. And I don't want to hear about sliced bread.
You're right in that though. But I think going back to what you rightly mentioned about the profit ratio was something that of course is a reality that every mold maker has to face no matter what. So I think perhaps a software or technology that is cost efficient,
yep,
could perhaps change their minds and open to the fact that perhaps we need to incorporate it so that we can provide the best service and at a price that is affordable to us.
And then right after you do that, you have to provide a win. It has to demonstrate that $100 or whatever the number was worth the investment, both in time and capital. And then I can say, look, I use this software because as a tooling engineer, I want to be able to blow my own horn. I was smart enough to use this software to simulate the fill and the cooling and the warp. And here we got a winner. I want more business. That's what the mold maker really has to do. Sure. They're not great salesmen typically. But if they've got a winner, they need to get out and win.
Yeah, and they need to tell it to the world that,
Absolutely. Absolutely.
Yeah. Last question I have here is, which is, of course, as we were talking about, there could be a difference of point of view between a part designer and a mold designer, and then perhaps someone who is producing the part manufacturer. Now, of course, you have had a chance to actually somehow be in contact with all of these stakeholders, though. In your view, front-end simulation, which we also discussed a little bit in our interview, or in other words, an early design simulation, do you think there is a chance of reducing that miscommunication between all of these stakeholders, such as the mold designers and the plastic part manufacturer, when a simulation tool is used?
Absolutely. It's if you're going to use the tool, right?
Yeah.
The best place to use it is early on in the design. After you've done your initial DFM and you say, well, that's a stupid part, we can't mold it no matter what you do. You want to be able to sit down with the molder and the product engineer and the mold maker. If they're going to work in a concert, they have to be sitting face by face and evaluating the information that they get back from any tool, whether it's a CAM program for machining the mold. Well, if we had a little more draft over here, we could use our 5-axis machine instead of having this. Whatever the application is, being able to address it face to face and early on will always improve the end result. If you run a flow simulation after the mold is fully designed and half built,
good luck.
Good luck, right? So yeah, if we can solve the problems before they are a problem, I'm all for that. And I think that early collaboration, I don't like that word, but early working together is the best place to do it. If you're doing it during a preliminary design review, oh, perfect. Everybody can sit down. The tool maker can say, okay, we're going to drag here, we're going to drag there. The molder can say, yeah, I think we need to do, and the product designer can say, this is what I want it to look like.
Exactly. So we're all happy.
Well, we may not all be happy, but at least we're all being heard.
True.
Okay.
And that is a very important part, because you don't want all the stakeholders who have been in the process to feel unheard, and then if it does not work, then the blame to go around.
The blame game stinks. Nobody wins in a blame game. But that's the thing, when you're communicating and you're talking about the issues, you don't want anybody to go away feeling dismissed, right? You want them to feel included. That's the goal. If we're all included in the decision, we all have ownership. We all propel the project forward. But as soon as you have one person dismissed, oh, you're stupid as a bag of rocks, you can't do that. Boom, that person, no matter how good a job everybody else does, has a sour taste, and your potential for success goes way down.
True.
Yeah.
Well, I think that is all I had for today, Scott. Thank you very much for giving us your valuable time and all the knowledge that you have given us. I can assure you, new entrants into this industry, mold designers, part manufacturers, name it, will be able to really use this information and benefit from it. I sincerely appreciate your time.
Well, thank you for reaching out to me, Hamza. I appreciate your interest in SPE and in all things plastics and how we can work together. I look forward to meeting you again at another trade show or before.